All right. So, yeah, I should have rebooted my computer yesterday, but this does work in GIS. I was going to do another example, but I don't know if I should because I don't think it'll work either. Anyway, we'll go back to here. All right, so just like with correlation coefficients, with regression, you can run an inferential analysis that will allow you to test a hypothesis. And here, the hypothesis that you're trying to test is that the population coefficient of determination is not significantly greater than 0. In other words, what you're trying to do there is say, is this explained variance significant? You can also test the model significance of the y-intercept and the slope. Both of those show up in Excel and in the report that I wasn't able to show you earlier. They do show up in ArcGIS. In the analysis, let me show you where they show up, because they're named almost the same thing in both Excel or ArcGIS. So I didn't save it, but it'll take a second to run it again. View, data analysis, regression. Okay, this should be the same analysis already. So. Yep. Okay, so they all show up in here. Okay. So this is the significance of the relationship right there, that value. That's the p-value. So that p-value is very, very tiny. What's a tiny p-value always mean? It does. It means to reject a null hypothesis. So that means that the coefficient of variance is significantly greater than 0. That's this one. So the sponge does remove a significant of the total variation for the bucket. All right. Now the significance for the y-intercept value and the x variable, the slope, are right here. So these are the significant values, and those are also significant. Okay, so those are significant values. Now the book doesn't go into how you calculate these values, but they are t statistics. It does go into how you calculate this value. This is an f statistic, so it's on the f distribution, the way that you get that f distribution, there's a few different ways you can get it, because remember that sponge is the ratio, or the ratio of the water that the sponge got to all the water is the R value. So one way that you can get that value is to take the R value and basically just rearrange this so that it's got the R value squared times n minus 2. Times n minus 2. In other words, the number divided by 1 minus R. So that ratio will give you a value on the F statistic. And remember with the F statistic, you needed two degrees of freedom, because one was on one table and one was on the other. So these are your 2 degrees of freedom. So you got 1 degree of freedom with the regression, and you've got 74 with the residual. So it's 1 and 74 is from the F table to find that significance value. But on this case, it's going to be off the chart. The other way to get that value, so this is the F value right here. I mean, I could prove that it's this R square value times n minus 2, which would be this minus 2 divided by 1 minus this. And I have to do order of operations correctly because I didn't do it earlier. So see those two numbers are the same, you see that? Okay? It's also the ratio of this mean squares divided by the residual mean squares. So it's also this number divided by this number. See it's that number right there? So the reason that math works out is that the sum of squares is what's being used to calculate the R value. We already found out that. The ratio of this number to this number, right? And the combination of that specifically is looking at n, which is the total. And so in a way, you're getting a mean value. So you're getting an overall value. So it's always this ratio of the mean squares, or another way to think about it is that this formula. But it works out to the same math. All right. Okay, so this is an example that's in the book, but I was planning to do another example in ArcGIS, but it doesn't look like my ArcGIS is working, so we won't do that. But this is a good example. So this is looking at the lake effect snow is what it's looking at basically. So when you have wind going in a certain direction always off of the lake, it has the effect of driving precipitation. So it's not just snow, but driving precipitation in a nearby area. Oh, it is snowfall. So if we look at a scatter plot of snowfall and distance from the lake, it looks like this. And you might actually get a relationship that looks like that for something that you're doing. And in this case, what we can do is say, well, it looks like maybe really, really close to the lake, there's this weird relationship. Maybe the clouds haven't gotten heavy enough, and so there's not a way. The snowfall is actually inversely related right next to the lake, but only like 6 miles away from the lake. As soon as you get 6 miles away from this lake, it looks like there's a very nice pattern. Okay, it's a lot of snowfall and it's falling off gradually. Okay, so one thing that you could do is just throw out that area and realize that your X domain is this area now, and establish a pattern inside of your X domain. And that's what the book author does for this example. So he throws out these 5 stations that are less than 6 miles away because they don't fit the pattern. And when you do that, you have to remember that you're now making predictions in this area, not in this area. Okay. So here we've got the distance from Lake Erie and the average snowfall. So those are the 2 columns that we're examining. If we throw those 2 columns into a analysis in Excel or in ArcGIS, we get a table like this. And the table is going to look just like this. We'll have the same numbers, but it won't be formatted in this manner. Okay? But we're still going to be able to see all the values that you need to see. We're going to see the sum of squares for the regression model. That's the explained variance. This is the unexplained variance. This is the total variance. So R squared is going to be the ratio between this and this. That's what your R squared value is. It's telling us our R squared value is 0.881. That's the amount of squared variance. Okay, so we can test the significance of it. It's got a p-value of close to 0. Predict the average winter snowfall in a new property that's 20 miles from Lake Erie. Well, the way that you do that is you take the slope and the intercept values. Those are right here in the table. If we were to go back to our table, they're these values right here. These are the values that are used to predict a new value. Okay. If I want to predict a new value, that's how I do it. I predict a new value by plugging in the distance, and I get as a response the Y value, in other words, how much snowfall will occur there in a year. So my prediction is 80.2 inches. Right? if I want to get a good idea, we already talked about a little bit about what standard error can help us to do. It can help us to standardize those residuals. But also, this standard error value tells us what's about one standard deviation in our model. Okay, so we can look at that. Oh, nope, sorry, this one right here tells us about one standard deviation in our model, because this is the x variable. So on here, the x variable, the slope, here's the standard error right there, 0.11. So one standard deviation off is about, yeah. 1 unit off is 0.1137. So we're off by, we could be off by that on average on our prediction. Okay. All right. And that's the example that's given in the book. So, let's talk about the homework real quick. So for the homework, I like I said last week, I think you should do the homework using a software package. Okay? All the data that you need to do, it has all the data you need to do it using a software package. So you still have to state the null and alternative hypothesis, so you're still getting to answer the question. Okay? In each case, so here. You can leave out and not do 18 yet until next week if you want. So in each case, you have to be able to find on the table all these values. So let's practice really quick. So even though this isn't looking at the same data that we're looking at, this is winter temperature and dissolved oxygen. This is what you're going to do. Let's find these values on the table. The equation of the least squares regression line, including the y and the intercept slope value. Where do we find that in the table?
That was on the scatter plot.
It is on the scatter plot, but it's in the table as well. So yeah, you're right. I got rid of it in the scatter plot, but you could, if you go to add trend line and you say display equation, you can get it right there. See these numbers though right there? They're also the same as these numbers right here. So when it says the equation of a least squares regression line, look for the y-intercept and the slope. They're labeled coefficients in most tables. Okay. The equation, the explained and the unexplained variation, that's not on the chart. Where do I get that from in this table? Because this is how almost all the tables, every table I've looked at that does regression analysis looks like this. So where's the explained and the unexplained variance on this table? That's the total variance. Yep. So which one of these two is unexplained and which one's explained?
Regression is explained and residual is unexplained.
That's right. Yep. Another way to think about the residual is the errors, the differences. So these are the unexplained variance. This is the explained variance. Okay. All right. So that's the explained and the unexplained variation. The coefficient of determination. Okay. What's that another word for? That's just a fancy word for something that we've talked about already.
R squared value.
Yes, that's a fancy word for the R squared value. It's right here. If it weren't there, it's just the ratio of the explained to the total variance, but it is already there. Okay. Which number, what do you mean? The coefficient? What slide? Oh, okay. Yeah, well, it's C, 1C. But you're going to have a different, you're going to run this on chapter, so this is actually chapter 18. But the thing is, you can do multiple regression, and you're going to have the same exact numbers. So there's not a whole lot of new information on chapter 18. I debated throwing it just in here, but I mean, I probably should have. Okay. The standard error of the estimate. Where do we get the standard error of the estimate from? Here's the standard error of the intercept and the variable. I don't know if it's on the table anywhere. We calculated standard error before, remember? It's from this slide right here. Let's see if it's on the table anywhere. So we calculated the standard error. Nope, too far up. We calculated the standard error on this slide right here, the standard error of the estimate. Okay, so it's the sum of all of the residuals squared divided by n minus 2. Let's see if it's there. Equals the sum, or sorry, we need to, equals this times this, fill down. So those are all the residuals, and then we need the SQRT of the what's the sum of all this? Yeah. I accidentally deleted. There we go. Yeah. So it's the XQRT of the sum of all this value divided by, oops, the sum of all those values divided by n minus 2. Yep, there it is. Sorry, it's right there at the top. Of course, ours is slightly different. I don't know why. I'm not exactly sure why our number is slightly different. But that's the standard error of the estimate right there, and our number is close. The sum of the residual values divided by n minus 2, take the square root. That's what we did. Oh, maybe it's because I don't have parentheses. Let's try it. Yep. It's the order of operations again. Sorry. So that number right there is the standard error. And the standard error is actually, before I kind of messed up. I said that the standard error of the slope was the plus or minus. This would actually be the plus or minus. So any predicted value, that's one standard deviation and one away from the model. So in our case with days, you would predict that if you came up with a given prediction for any area based on their latitude, on average, you'd be off by about 8 days. If you wanted to create a confidence interval, you'd have to multiply that by the standard deviation, by the z value for that confidence interval. So for example, if I wanted to predict a value of, at a latitude of 30, if I wanted to predict when frost would come, I would say it's equal to 30 times the slope plus the intercept, and I'd have to put it in like this. So that is the day of the frost at 30 degrees north latitude. That's in just barely in early February. Okay. So that's using this formula here. See, I've used that formula. That's coming up with a prediction. Now, if I wanted to actually give a plus minus, I would have to multiply this times I'd have to multiply this times 1.96, which would be like the confidence interval for what is 1.96 is 2 or 3 standard deviations, the z-score. Let's look at the z-score real quick. The z-tables are,
95%?
what's that?
Is that 95%?
Yeah, it should be 95%. I think that's the 95% confidence interval. So if I multiplied out that by 1.96, and I would get a value, and if I said this value plus this, that's the latest spring would come, well, the last day of spring frost, and this minus this is the earliest spring would come. Okay? Now, you have to be careful using these values, and the reason is because, go back to here, this looks really what do you call it? Scattered, and there's no pattern to it. But if there was a pattern to it, you shouldn't be using a confidence interval, because the confidence interval assumes that you've got a really kind of shotgun pattern approach to it. And so when you're predicting a value, it's assuming that the variance is the same all along the model. You've got the same variance all along the model, which isn't always the case. But this one looks pretty like a good candidate. So we could express a confidence interval. So for any given place within our geographic area that's at 30 degrees, that's the confidence interval. All right, and the book does not actually talk about that, but all right. So the standard the estimate, the test statistic for R squared and the p-value. Where do we find that on the table? Well, the test statistic is the f value. That's the test statistic, and then that's the significance value. So those are the two values, and all of the questions ask the same basic things. So your task is to run these things through and get practice asking or deciding whether or not there is a relationship, and looking at that. So you're doing that for each of those examples. So it looks like you're doing 1, 2, 3, 4, 5, 6 times with different data. All right. You can do it in ArcGIS. If you do it in ArcGIS, though, it has to be spatial data. I don't know if you saw really quick how I did that. If you have a table that has latitude and longitude in it, you can pull that in and make an XY data set with that. All right. Yeah.
How do you get the analysis tool in this? I thought you went to options,
Yep.
then
Let's-
add-ins.
Let's make sure you can do it. So you go to File, Options, and then, did you go to Add-ins?
Yep.
And then once you're on Add-ins, you go to Go at the bottom.
Okay, you don't need to highlight anything?
No, just hit Go.
All right.
And then you turn on the Analysis Tool Pack to check at the box. Not Analysis Tool Pack VBA, just Analysis Tool Pack.
And then just okay.
Yep.
Okay, it's still not showing up on my thing.
Then you go under Data. Data. And then,
Thank you.
oh, no problem. If anybody has any questions like that, that's great. That was a great question. Okay. All right. So, I think we got through that. All right. So, a few announcements. What I did was I changed the due date of this stuff. The due date of this all three of these isn't until for 2 weeks, which would be the last day, which would be the day of the final. Okay, oops, just making sure I did this right. So the due date of all three of these exercises is is May 4th, which is actually the day after the final. So what we're going to do for the final is that, did I already say it's going to be take home? Yeah. So it's going to be take home, and what we're going to do is that next week, I'm actually not going to be here. So next week, what I'm going to do is make a video explaining the last thing, just the multivariate regression. It's a pretty, I almost could have included it this week, so it won't be a full 2 hours of talking. But what I am going to do is talk about geographically weighted regression, which is another tool in ArcGIS, and a few of the other regression tools in ArcGIS. So I'll do that next week on a video, and then wrap up the course. And then at that time, even though I won't be here, I'll also put up the final exam. And the final exam will be similar to the first exam, except for it won't be in class. You'll just do it. You'll answer the questions, and yes, it'll be a downloadable, like a file, just like the other thing. So you just answer the questions and send those back to me, and I'll make that due actually the week after. So I will be back. If you have any questions on the final for the last 4 days of the final, before the final is due. Okay.
So what is the due date on the final?
The final will be due
7th
the.
or 10th?
Let's just make it the 10th. Yeah. Final on the 10th. All right. So that's the schedule. So next week you get a video presentation. There won't be anything on the day of the final. Won't be anything. So don't even show up on May the 3rd. And if you need help on the final, I'll be here this 7th, 8th, 9th, and 10th. So if you have any questions, I will be fairly easy to access by email, but I won't be here. So if you have a question, you can ask me by email, or wait till I get back. All right. Does anybody have any questions about that?
So we won't meet again for this class?
That is correct. Yes, that's a good way to summarize it. That's sad.
It's very sad.
It's all right.
So there's no more programming either.
Well, the programming will be the same way. We're meeting today.
Yeah.
And next week will be a video presentation. The week after that would have been the final, but the final will also be taken.
So, but the video will be online for us to watch. We won't like come to class.
You don't have to come to class, sure. So in both cases, you don't come to class. Right? Both classes take home final. Of course, that only applies to actually.
Well, no, Matthew's in
What's that?
Matthew's in the other.
Oh yeah, Maggie's in the other class. And Ella does in the other class. All right.
So your tape class, we don't have to come in here to view, or we're just gonna.
It'll be online. Just download the. Just watch it on YouTube.
You could Skype each other.
I could. I don't know if I'll be on a boat or not. I have done that before in my classes once. I Skyped class, and it worked out okay, but the thing dropped every once in a while. So, and I will be out working, so it's easier if it's a night class than a daytime class. Plus, I'll be on Atlantic time next Thursday. That'd be 2 hours off of our time, 2 hours earlier. I guess that.
We will gratefully accept your tutors.
Okay. Thank you.
I didn't mean to imply you should Skype. I just mean I'm very sad that we don't have any more stats.
Well, yeah. I mean, the book's almost over.
Oh, I'm not.
More stats?
You can never have more stats.
Yeah. Well, today we'll be doing more stats in the other class.
Oh, that, okay.
We're basically going to talk about regression in that class too, but we're going to use Python.
Oh, cool.
Yeah. All right. Well, that's.